Hello there, and let's have a quick look at this question. So it goes here, the diagram shows a curve y equals 1 minus x plus 6 over root x, and the line L, which is normal to the curve at 1, 6. So at that point, L is normal to this curve. Okay. Right. Determine the equation if L, A, B, C are integer values to be stated. Okay, so they are perpendicular at that point. So the first thing is, let's grab this curve. We're going to say y is equal to 1 minus x plus, and I'm going to bring that, well, first of all, you should know that the square root of x is x to the half. And the second thing, you should know that when it's at the bottom, to bring it to the top, you negate the power. So that will be 6 times by x to the minus a half. Okay, that's very important, you know that. Now, if I differentiate this, dy dx, which is the difference in y over difference in x, which is going to give me the gradient of this curve at that point. So that will be, take the power, well, constants goes to 0. There's only 1 there. Take the power down, take 1 of the powers, that becomes minus 1. Take the power down, which becomes a minus half times 6 is minus 3. And take 1 of the power, which becomes x to the minus 3 over 2. Okay, so now we've got the gradient equation. At any point here, we just need to sub in the x value, which in this case is 1. And it gives you the gradient of the curve. Now, before I start, I'm going to rewrite this and say that is the same as minus 1 minus 3 over, now, x to the power 3 over 2. Now, really, that is x is being square rooted, then cubed. Okay, just in case, but because it's 1, don't need to stress too much about that. If you want, I can rewrite that. Let's write it here, which will be minus 1 minus 3 over x square root, then all cubed. Okay, and now that is the I'm going to call gradient of the tangent at any point x. So if I say x is 1 here, gradient of the tangent in x is 1, you sub it into this, that's minus 1 minus 3 over 1 square rooted is 1 cubed is going to be 1 still, and that's going to give me minus 3 over 1 is just minus 3, so minus 1 minus 3 is minus 4. Now, done that bit. Now, if we want to find the gradient of this, which is the normal, I'm going to call that mn. I know that because they're perpendicular, mt times mn, this is the gradient of the tangent, gradient of the normal. The product is going to equal to minus 1 since they're perpendicular. Okay, now when they're perpendicular, I know that therefore that's just going to be the reciprocal of that negated, so the gradient of this line is just going to be 1/4. Okay, once we got that, we can now, I'm just going to put a line here so we're not getting confused with the working out. Now we just need to put the coordinates, because this is the gradient, and to get the equation of L, it goes through the point. So I'm going to put equation of L is going to be x minus this coordinate, which is 1. Actually, I should put that on the other side. Okay, so we got, first do the y first. So y minus the y coordinate is 6, which is equal to m, which is 1/4. X minus the x coordinate is 1. I should have really stated the equation. You should know this equation. x minus the x coordinate. So that's the equation I'm using to find the equation of the line. Okay, so once I got that, expand it through, y minus 6 equals 1/4 x minus 1/4. Bring everything to one side, so that will be, well, let's do this. Let's just times everything by 4. Let's just get rid of the fractions because it wants it all in integers. So that's going to give me 4y minus 24 equals x minus 1. Okay, and it wants the number on that side and all the letters on that. So let's take that to the other side. So I'll get 4y minus x. I'm going to take this minus 24 to the other side, becomes a plus 24. So plus 24 minus 1 is positive 23. Okay, so that's going to give me in this form. If you want to put the minus x in front, it's not a big deal. Okay, I'll personally put it like this. That's that one done. The a, b, c are integers here. Okay, we've done that one. Next one, verify. As I say, verify that the curve intersects x axis at that point, x equals 4. Now when we verify it, we just need to plug it in and making sure that it satisfies that equation. Okay, so verify the curve intersects the x-axis at 4. So if it's going to intersect the x-axis, okay, verify it intersects the x-axis at 4. If I put 4 into this equation, the curve, it should equal 0. So let's just quickly do that. So y is equal to 1 minus 4, because x is now 4, plus 6 over square root of 4. So that's going to be 1 minus 4 is minus 3, plus 6 square root of 4 is 2. So that's going to be minus 3 plus 3, which is equal to 0. And therefore, that says it's 4 long and 0 up. 0 means it crosses the intercept. Okay, it intersects the x-axis. So we're done with that one. So that's straightforward, one markup, no problem with that. Okay, it goes here. Find the exact area of the curve. Exact area of the shaded region enclosed by L, the curve, and the axis. Okay, so yeah, let's do this in two parts. First of all, I'm gonna bring that down. So you've got two sections here, and you have got so that is axis 1 there, and axis, I'm just going to rub that coordinate thing off here. And that here is 4. So I'm going to do two integrals. I'm going to find, because the area is the integral is basically when we do the integration under the curve or the line. So if from here to here we've got the straight line, so we're going to need to integrate that between 1 and 0, and then I'm going to add on this integral between 4 and 1, and this is the curve. So where's my equation of the line? So really I need it in so let's put a line here. I'll do two integrals. First one's going to be, let's set it up here, then I might come along there. So first one is going to be the integral. Now before we do the integral, this curve was this. So if I make x the subject, y the subject, which was here, so this will be 4y is going to equal x, because I'm taking that to the other side, plus 23, and then divide it by 4, so y would equal 1/4 x plus 23 over 4. Okay, so what we need to do is integrate between 1 and 0, and this will be 1/4 x plus 23/4 respect to x. So basically this means integrating between 1 and 0 this line, okay, this equation, which is respect to dx, all the way along the x-axis, going all the way down, okay, respect to x. And then we're going to add, and that's going to be from 4 to 1, from 4 to 1, so we're going from there to there. This curve, and the equation of this curve is going to be this one here, which is 1 minus x plus 6 over, you can just leave it as that because we're just going to do it on the calculator, and then dx means respect to the axis. So basically we're trapping the curve with the axis between those ones. Okay, so if I did the first one on my calculator, this one, so just plug in your calculator. I know you can do it without, you're not going to get any extra marks. So we've got 1, sorry, delete that, x over 4 plus 23/4. Then you've got the limits 0 and 1. And that's going to give me, on your calculator, it should show you 47/8. That first integral. So that's all that area here. Now let's do the next one, integral again, and this one is going to be 1 minus x plus 6 over root x, and then put the limits in, which are going to be 1 and 4. This equals, and on your calculator again, it's going to give you 15/2. And if I'm adding those together, it's going to be all over 8. So you can just do it on your calculator. That plus 47/8, you're going to get an answer of 107/8. And that is it really. So that's, once you've got those intersections, you've got that for your integral. Once you rearrange that, you've got this equation of this line.